Hello everyone. So today we are going to discuss about the DoublyLinkedList Node implementation. So if you guys remember, in SingleLinkedList we directly started from the constructor implementation and the add first method. But in case of a DoublyLinkedList, things are pretty tricky and we need to discuss about the implementation of its node. And today we will also discuss little bit more about kind of a good coding practices, or like you should know your APIs properly, and when you will implement, you should implement by using the built-in functionalities So in what's the first, we can discuss what's the problem, and then after that we will discuss how to solve that. And for today's video only, the format is little changed. So first we will discuss on a whiteboard the problem and then the solution, and in the second half we will do the coding, and that is only for this video. And then from the next videos for the DoublyLinkedList we will use the same format which we are following for the other data structures. So the first, what is the problem? We can go with the SingleLinkedList. So if you guys remember, in a SingleLinkedList we have a class node which have integer value, and then is also contain node type, and which is optional and nullable. So we use this. And now in case of a Java or a Kotlin, we have the opportunity to print information by using toString. So before going to this, we will discuss a little bit about the toString method, and then we will come back to this. So if someone is not aware of that, that will be good for him or her. And if you are already aware of, you can skip maybe some 3-4 minutes of this video. Okay, so what is the toString method? So every time when you have a Java object, there are built-in methods, hash code, toString, and if you don't implement, so for example, I have one class, maybe class, and its name is whiteboard WB, and that has some implementation, some fields and different things, but I'm not implementing toString method. It means it will use automatically the default. So in case of a main method, if I'm using print or println, and I have an object WB, like for example WB is equal to new WB. In case of Java, in case of Kotlin, directly I can write WB. And once I will do this, in this case I will see it will print on a terminal with something like class name WB@39AF, which is mostly called like it's a memory address. So that is if I'm not writing my own toString method. Now if I want, once we will do print some information that will show something which makes sense. So in that case, what I need to do, for example, this whiteboard has some field string A and integer B, and I want to print this information. So what I will do, I will say, okay, public void, and this is the override method, toString. It will return a string. Okay, sorry, I used the wrong syntax. I mix Kotlin and Java, but in case of this Java, it should be public string toString, and here I will return A plus B. So now if I will do print WB, it will show me what is available in A and B. For example, I have A, which means maybe I saved name Hafiz, and in B I saved 2, so I will add space 2. So it will print like this on a terminal. So that is the toString method. Now one suggestion or one recommendation, every time when you are writing code for debugging in your production code, don't write the print methods separately like print something. Always go and override toString method. It's a good coding practices in my opinion. Okay, now coming back to the string, the node. So in case of a node, I'm using for example the Kotlin syntax, so data class. So basically data is kind of a equivalent of Pojo, which has get setter method, and this is our constructor. And if I don't override the toString method, Kotlin is saying data class I will write for you. So I will get that is free. So maybe I can write proper definition. So we used to have this, and then we have value, which is type T, and then we have, and this is also val, then we have variable, which is a next node, which is type of node T, optional, and by default this is null. So this is our definition. If you forget, you can go back to the singly linked list implementation and you can review there. So this is our node for the singly linked list. And when we implemented in a main, so for example I have a list L, which is a singly linked list I created somewhere, which contain the nodes. If you guys remember, in case of a singly linked list, we have a method class singly linked list. All the methods, I have a head pointer, I have a tail pointer, size, blah blah blah. In the end, because I'm using Kotlin syntax, so we did override fun toString, and here I said okay, return head, simply head. So that is our implementation. And in case of a main, I added some values, add first 1 2 3 4 5, and we did print L. So in this case, basically on a terminal we can see 1 2 3 4, a proper node, which is saying, like, it looked like, if I'm not wrong, it looked like on a terminal node value equal to 1, then it start node, next node equal to, now again it started node value equal to 2, like it's showing like this, so nested. So it's kind of a recursive toString call. Until now there is no problem, we can see how it's working. Maybe I can spend a little bit more time. So basically what happened when I said print L, the singly linked list, basically this L is saying go and run my toString method. Okay, in case of a toString method, this head is a node, so this head is calling this node's toString method, and that toString method is implemented by default from the Kotlin compiler when we compile the code due to this data. And that implementation looks like this: a whole class variable is showing, so it's showing okay, class name node, then the parameter value 1, then the next node what value is here. So in this case, how this works, so assume this is my list 1 2 3, so this is my list L, and there is internal implementation of head. So once I'm saying print ln or print L, it's calling okay, go to the head, and once we will call head is a node, basically it's internally saying okay, call toString. Okay, so when that is called toString, in that toString, for we are calling basically for head this, so it will print 1 information node 1, then the next time when I am on a next node, head dot next node, it will call again that next node toString method. So it's a recursive by default implementation. It will start from here, recursion go to the next head dot node dot toString, Once toString call on this value, which will show 1. Then on a next node, when toString call on a next node internally, it will call this now. So it will show 2. Then for 2, next node toString call, it will be 3. And then when it will come to this next node for a 3, the toString, because it's null, it will say no more. So it's kind of a base condition automatically. You can do that experiment. So this how it's working under the toString method. Now what is the problem in a doubly linked list? So in case of a doubly linked list, before going to write the node, we can see how it look like. Doubly linked list is like this. So I have this next node, this previous node, value 1, 2, 3, next node, this previous node. In this case, if I don't do the if I don't tackle this toString method properly, we have an issue. We will get the stack overflow. Why? Try to understand. So this is a next node. When I call the next node dot toString, that will move here. Okay. Now at this node, because every parameter toString method is implemented, so on this one it will say, okay, call now previous node dot toString, and once previous call dot toString called, it will come here, and now we are stuck in a loop. And once we are stuck in a loop, there will be a stack overflow. And how we can fix, now we will discuss. At this point, we need to implement our toString implementation, and we can't use the by default Kotlin's toString implementation. So again, the node should be looks like the same, just like before. We have data class node, it's generic, so T, then it has a value which is value T, then variable next node which is again node T, and this is optional, and by default this is null. And then the third one is variable previous node. So this is our node class. I have somewhere doubly linked list implementation. Class doubly linked list implementation. Inside again we have head methods. Somewhere I need to write toString. I'm going to override, and I will say return head. So by doing this, it is saying, okay, head is the node, move towards the node. So now if I create list doubly linked list, and for example I add first called 1 for 2, then 3, then 4, for example for 3, and I'll say print L. Now we try to understand what will happen in this case. So L is saying, basically this is DLL, check the toString class. toString class is saying, yeah, I have override it, so it's saying, okay, call head. Once we are calling head, you can write head.toString if you are not comfortable, but every time when you call directly an object, it's always call its toString method. So this head will go to this node because it's a node type of T. It will come here. We are not giving any override, so it will take the internal implementation. toString method called for head is called for 1, so it's saying toString for 1. First it will print value 1. Next it will say, okay, next node, which is this, called is toString. So in this case, my stack is like this, and I have 1, and now I am calling to the next node. In this case, we will jump in here. Now we will come to 2, and now I'm calling next node again, and this is still in stack. Okay, now we are here. We called 3 and 3 next node is null. So 3 next node is null, nothing will happen. Then it will go to the previous node. Now 3's previous node is this one. So it will now push 3 on a stack, and now it will call this node. So its value will print now 2, 2. Then in this case, what is next node? So it will go again here and it will say, okay, call the next node and push this. So now this one, push means the internal memory of a RAM. So now 2 is again in our memory and I moved here. Now here again 3 will be called. Then next node is null. It means its previous node will be called. It will come to this. It will push again. Push means again in a memory method call. So it's increasing the stack, and again 2. So now in this case, what will happen? We are stuck in a loop. So I'm moving here and there, and at one point there will be stack overflow. So now I hope you understand what is the problem with the built-in toString method. So how we can fix? We know we need to fix by implementing our toString method. So now we can see how we can fix. So in that case, what I will do, I will say, okay, override this fun toString. It will return string, and I can do what? Return build string. Okay, if you're not aware of this, this is a basically string builder implementation in Kotlin. It's pretty handy API. So in this case, you will see, you will understand. Build string. Okay, so I know the problem is with the next node and the previous node, mostly in the end. Once I will come in the end, it will go back to the previous node, then next node, then previous node. So I need to break somehow that loop. And how I can do, I can fix by using the same strategy which we have in a single linked list. Next node, next node, next node. There will be no need for the previous node. Or maybe I can take a previous node, previous node, previous node. So I'm going with the next node, next node. In that case, I will say, okay, take only that next node and print the information about the next node and move towards the next node, and only toString for the next node. And there is no need to call for the previous node. Instead, print the information of a previous node. Like what I'm saying, I will show here, it will more easy to understand. So first I will say, okay, if previous node equal to null. So if my previous node is null, what you do, you can do append because it's a string builder. So, and I will say, okay, null. I did append null. Else if you are not null, then what you will do, you will say, okay, append, and I can add the value previous node and pn is equal to, and give me the data of the previous node. I will share with you what I'm trying to do. Pn equal to show the data of previous node dot data. Okay, so basically it's simply like add in a, so I'm making a string by putting this information. Then also I will say, okay, append the, this is not data, sorry, this is value. I'm using value. Now here I will say $value. So dollar means in a string, if I want to do a string interpolation, we can use directly string value inside of a string. In case of a Java, mostly we write like this, value plus string. So this is same. Okay, now append the value, then move towards the next node. Equal to null. If you are null, then append null. Else, in case of a else, what I am looking for, I'm saying now start the recursion, and in that case what I will say, okay, append. One thing to print format properly, I will say okay, next node. So pn is the previous node, I'm using next node is not null, and then after that I will say line break and then call next node or next node dot toString, both are same. Then this is finish. Now we will see what will happen. So in this case, please remember how we implemented this. I have a list, for example, DoublyLinkedList for 1, 2, 3. So next node, here next node is null. Then this one is a previous node, and this one is null. Okay. Now in main I call print ln or print simply my list name L, and now what will happen? It will move towards the DoublyLinkedList implementation toString, where it will call the head, and this is our head. Head will call its toString method. So currently this is the head toString method. Now in this case what will happen? It will go inside. It will check previous node is null. Yes, it will start appending the string. So our string start look like this, null. Then append value. So it will say 1. Then next node is null. No, next node is not null. Write n is equal to not null. Then line break like I'm here and call the next node dot toString. Okay, in this case I'm here. Next node dot toString means now I'm here. So this is my current toString. Now toString called for this method. In this case I will be back. I will see previous node. Is previous node is null? No, in this case not null. Then what is the previous node? I'm saying okay, put this pn previous node is equal to previous node dot value, which is 1. Maybe I can put like this so it will be easy. Then show me the original value of that node, which is 2. Then go and not null. Okay, now toString is called for this next node. Here again pn equal to 2, then the original value is 3, and in this case null. Okay, I hope now everything is clear. So basically what we did, we formatted our DoublyLinkedList from the readability perspective, because in coming videos we need to see a lot of time where we are in a DoublyLinkedList, what we implemented. So I took this format. If you feel we can improve this, please write a comment and I will improve this. So now what will happen in this case, every time when we have a DoublyLinkedList and I will say print list, it will start writing in this case. So every time we have a previous node and the next node and the value. So center is always the value, previous node always on the left side, on the right side, and the next line is always the next node. And how we will confirm previous node is properly linked, I'm showing not the address, I'm showing okay, show me the previous node value. So now from here I can confirm, okay, when I'm here, this is 1 is the original node. When I'm 2 is the original node, but what should be the previous node of this 2? Should be 1. So by comparing this previous node value is 1, I can give you guarantee this is working properly. Then the same thing happened at 3. I want to confirm, is 3 previous node is properly linked? Yes, I can see because the previous node value is 2. So by implementing this format, we can see all this information easily. And now we can move towards the coding part, and hopefully until now you really understand. We have a problem because there are two links, previous and next node. It create a loop when we are going in a recursion. So to break that loop, we implemented this technique or this method. And I really feel this is a good question also to ask in an interview, but we need to write a proper problem statement. And after that, you can understand easily if the person really know how recursion works. If he will figure it out, there is a problem, and then the base case. So yep, moving towards the coding part. First, we need to create a DoublyLinkedList class plus the node. Okay, we can start data class node t, and then just like we discuss, value which will be t. Then we have a next node which is optional and null, and then we also have a previous node So this is our data class, and we will override toString later. First, I want to show you the problem. So this is our DoublyLinkedList, and again we will follow the same strategy how we implemented SingleLinkedList. We will add all the fields as per the requirement, as per the usage, not we will put everything in start. So first, as we know, we really need a one head pointer, and which is a type of t, and which is nullable. Then the most important part, you guys remember, we need always a variable size who is responsible to take care of the number of elements in a list. If I don't have this, if you guys remember, if I don't have this and I want to understand how many elements I have, I need to do a while loop from head to until end, which means that is a big O of n operation. But by putting this only one variable size, I make that thing to the big O of 1. If you are still confused, please go and check my SingleLinkedList, I think so, the introduction or the first method, first video of that, and you will understand what I'm saying. And now the next thing is we need to call, first is our toString method for so in this case what I'm saying okay, we need to call the toString method for this DoublyLinkedList, and this head is basically is a node, so it's originally go and call its toString method. Okay, for now what we need to do, first I need to show you the issue which we discussed. So I'm saying okay, create a list of DoublyLinkedList, and this maybe integer is okay, and then add some values dot add first maybe 3. Okay, so in this video we are not going to discuss add first, that will be our next video. But to add this data, I need to create this method. So for now I will not explain this, please ignore this method, and in next video we will discuss this. So we have a node which will get the value, the next previous should be null, and then I will say dot next node dot previous node should be head, and size should be plus plus, and this can be okay. So please ignore this method for now. And now I have this, so I will try to put values 3 to 1, and then I will say okay, print list. Now we will try to run. Okay, so now we have an issue, and which is a stack overflow. But if I only add one, in this case there should not be any stack overflow, because as you guys remember, both are null, next node and previous node, it will work. But if I have two values, this should show the stack overflow, because if you guys remember, on a whiteboard we discuss first is putting towards the next node, and next node is 2 is putting back to the previous node, and there is a loop. Okay, so to manage this, we need to implement override this method here. Before going to start to implement this, I think we can confirm what I'm saying. Is it makes sense? We will run and this should work. Okay, so it means the problem with our toString method, what we discuss, I will implement in the same way. So I have if previous node if is equal to null, then I need to append value null, else I am saying append previous value pn is equal to inside of dollar previous node dot value, and so this is our first implementation. Okay, I will add spaces so we have a proper and looks good. Okay, then we discuss I need to append the original value which is a value of that node, and then again the same check for the next node. If equal to null, I need to append value null, else what I need to do, I need to do the recursion call. First I will say next node equal to not null, and then line break, and then after that and then after that I will call the dollar next node dot toString. Now I will call this and we will see. So yeah, we can check. So you can see, okay, because at first means this is our head, this is our next node, and this is our last node. So it's saying, okay, previous node of 1 is null, which makes sense, heads always previous node is null. Then after that we have a 1, then this not null. Okay, I will add space here so it look more nice. Now run again. Now you can see previous node is null, yes, value is 1, next node is not null, yes, next node is not null, so I am now on a next node. So here I can confirm next node's previous node is pn is 1. Okay, this, and if I try to add one more value 0, and again I will say print. So okay, it looked a little bit ugly, we can improve. So I'm saying every time show my linked list inside of these brackets, so it will help us to understand. So yeah, you can see this is our first list and this is print of a second list where we added 0. So now you can confirm 0 1 2 3. Maybe we can try to also check at this point to run as a debugger, and then we'll see is it make sense what we are talking about. So at this point, head next node previous node next node next node previous node next node previous node previous. So we can confirm how. So this is value 1, okay, which is a head. Then next node contain the value of basically 2, yes, and next node address is 847. So next node is 847, which means we are talking about 844 847 address. In this case 847 is this, so its previous is connecting with the same, and then again from 2 to 3 the next node, and then the next node is null because 3 is our last node at this point,
and its previous node is putting with the 847. 847 is our second node, so it look like everything is properly working. I hope I'm able to share with you something new. See you in the next video. For now, bye.